Hi, welcome back everyone. So today we are going to solve a very important and very good problem of data structures and algorithm, which is finding the n by 2 major element of an array. So this problem has been asked in lots of interview, and if you are preparing for interview in data structures and algorithm, or you are solving problems on it, so this problem should be in your bucket list, and you should solve this problem. So let's begin the problem. So the problem states that you have given an array and you need to find out the n by 2 n by 2 you need to find out the major element of that array. There is a constraint which says that if the count of if the count of an element is greater than n by 2, then you need to return that element. So start the problem. So you have given an array of 2 2 1 1 1 2 2, and so the you can start the problem by saying the brute force approach. The brute force approach is like that. You can perform a linear search on the array, and you are going to use two loops for this approach, one for the picking element and other for checking whether if the element is equal, then we will increase the count by 1. So this the time complexity for this approach will be n square, and I'm sure the interviewer will not be happy with this solution. So he will say to optimize this solution, and the for the better approach of this solution, you are going to use hash map. So first I will write this solution. I'm going to initialize two variable, one count and one element. Or rather, I will be initializing only one element, one variable, and I will be starting with first loop, which is I equal to 0 till n. Then another loop, j equal to 0 to n, and I will write condition like if n of if a of I is equals to a of j, then count plus plus. This condition should be written inside the second loop, and out. Then after that, after closing this loop, in the first loop we are going to write if count greater than n by 2, so n is the length of the array, then return the element, which is return n of I, a of I. If there is no loop, if there is no n by 2 element, then we are going to directly return -1. So this was the brute force approach for solving this problem. Now we are going to solve using better approach. So for better approach, we are going to use an hash map for this problem. So basically what we are going to do is we are going to traverse the array, and we are going to put every element with the count inside hash map. After putting every element inside hash map, we are going to traverse the hash map, and we are going to check whether this element is greater than n by 2, then we are going to return. If not, next. If not next. If not next, until we get n by 2 element. If we didn't get anyone, then we are going to return n minus 1. So let's write the code for this approach also. So first we are going to create a hash map hs. After this, we are going to put every element inside hash map using for loop. HS dot put first I will be going to create a variable value for HS dot get or default method. Then I'm going to put the first parameter as element of the array, which is a of I. Then the second parameter, which is count, should be 0. After that I am going to use get or default method. I'm going to use hs.put method for putting the element. hs.put of I value plus 1. After this, we are going to iterate the hash map using entry set. If entry set dot get value is greater than n by 2, then we are going to return it. Then we are going to return entry set dot key, which is the corresponding key for that value. So that's it, and we are going to return it by -1 in the ending, because if there is no n by 2 major element present in the array, we are going to return it -1. This was the better approach, and time complexity for this method is for inserting each element in array. For inserting each element in hash map, it took log n time complexity. So we have n elements, so it will take n log n time complexity, plus we are going to traverse each the hash map, so again it will take n complexity, big of n complexity. So the total time complexity will be big of n log n plus n. Now we are going to discuss the optimal approach for solving this problem. So for optimal approach, just a second. Yeah, so sorry for disturbance, and let's begin again. So we are going to solve this problem with an optimal approach. So we are going to use an algorithm called as Moore's voting algorithm for solving this problem. So the algorithm is like this. If we have an array of 2 2 1 1 1 2 2, so this is our array, and we need to check the major element. So what we are going to do is, we are going to create two variables, one count and another variable element, and we are going to traverse the array only once. Like, for the starting index is 0 and the element is 2, so element is 2, so it will be count will be 1, and we are going to store the element 2 in the element variable. So we are going to store it then we are going to move ahead. Is 2 is the next element is equal to the element which is present in the element variable. Yes, so we are going to increase the count. Then so the element which is present in element variable is 2. Now when we move ahead, we got 1 which is not equal to 2. So we are going to decrease the count by 1. So now the count is 1. Again we got 1, so we are going to again decrease the count by 1. So we will move ahead. Again we got 1, so we are going to so when the count is equals to 0, we are going to put the we are going to remove 2 from the element variable, and we are going to put the new variable which is the new element, which is 1. Now we got 1 and the count is 1. So now we move ahead. We got 2, so again we are going to decrease the count, because the element is not the number which is present in the element variable is not equal to the current element. So we are going to decrease it again, 0. So when 0, then we are going to put the new element in the element variable, so 2. So the element which is retaining in the element variable is 2. Now what we are going to do is we are going to again traverse the array, and we are going to count how many times the element 2 has present in the array. So again I'm going to traverse. So from 0th index, is 2 equal to element variable? Yes, count 1. Again 2 is equal to again element variable? Yes, count 2. Is 1 equal to element variable? No. Is 1 equal to element variable ahead? No. Is 1 equal to again variable ahead? No. Is 2 equal to element variable? Yes, count 3. Is 2 equal to element variable? Count 4. Yes. So the count we got for element variable is 4, and the length of the array was 1 2 3 4 5 6 7. 7 was the length of the array, and n by 2. 7 by 2 is 3. So 4 is greater than 3. So we got our major element, which is 2. So we are going to return it. So now let's write the time complexity for this problem using optimal approach. So what will be the time we are going to write the code for this. So start with, we are going to initialize 2 variable with 0, and we are not going to initialize element variable. We are going to retain it. Now we are going to start with loop I is equals to 0 till n. If count is equals to 0, then what you should do, increase the count by 1 and put the current element of the loop in the element variable, this, or else if variable element is not equal to the current element of the loop, then decrease the count by 1, else increase the count by 1. So this is now again when we need to traverse it. So again we are going to put the count as 0. Now we are going to traverse the loop from ith index to from 0th index to till the last. If element equal to current element of the loop, increase the count by 1. So after this, outside the loop, we will again write one condition, which is if the count is greater than n by 2, then we are going to return it. So this will be the final condition, greater greater than 2, greater than n by 2, so we are going to return the element which is LE. So that's it. So the time complexity for this problem is big of n and space complexity is 0. So that's it for this video. See you next time. Bye guys.